subtracting equations or addition and subtraction equations. Topic 15. Assign seats, please. Solving addition and subtraction equations. An equation is a mathematical statement that two expressions are equal in value. An equation is a mathematical sentence that two expressions are equal in value. An equation has an equal sign in it. To solve an equation, you must isolate the variable. That means to get the variable alone, on one side of the equal sign. We get the variable on one side of the equation by using the inverse operation, and inverse means opposite. We've already talked about this before. You know the opposite of addition is subtraction. That the opposite of subtraction is addition. That the opposite of multiplication is division. And the opposite of division is multiplication. So we've already reviewed that some this year. Example 1. X minus 8 is equal to 17. Now, you need to look at an equation like a balance, where the equal sign is the middle of the balance. And you're trying to keep, because we've already said that this expression is equal to this expression. That's what an equation is. It's saying that two expressions have equal value. So that means if I did something to one side, to keep it balanced, I have to do the exact same thing to the other side. It's like putting something on the side of a scale. If I'm going to keep it balanced, then I'm going to need to do the exact same thing to both sides of the scale. So, the first question you're always going to ask yourself is, what has been done to x? X, we have subtracted 8. What's the opposite of subtract? Add. We just went over that again. So we're going to add 8 to both sides. Because remember, what you do to one side, you're going to do to the other. When we do that, that creates here 8 zero pairs. Because remember, if I do keep, change, change, they're negative 8s and they're positive 8s. And those are 8 zero pairs that cancel out. So I'm left with x on this side. I have just isolated the variables. I got the variable by itself on one side of the equation by doing the opposite of what had already been done to the variable. Now, what is 17 plus 8? 25. This is the solution. But when you are solving equations, there is no reason whatsoever why you should ever get one wrong. On anything I give you, on the EOG, on any math test, no reason why you should ever get one wrong. Because you can check these. All that you do is write the original problem, x minus 8 equals 17. And what we did with expressions the other day, with variables and expressions, we said if x was 25, then we're going to plug 25 into x. So I come up here, 25 minus 8 equals 17. What's 25 minus 8? 17 equals 17. Yes. And if they both equal, then you know that that is the solution. So you can always check by using the skill that we did, variables and expressions, in topic 9. You can go over and check to make sure that every time you do an equation that your solution is the right solution. X minus 8 equals 17. Bring your problem out to the side so that if you're using your Cornell notes the way that you should, then you're covering that side up when you get home. You're trying to rework them by yourself. You're pulling it down to see if you got the right answer before you move on with any additional homework or the classwork that you didn't do. Any questions about example 1? We're still on topic 15. Example 2. And I realize that these are easy. I realize that they are positive whole numbers, and that because a lot of you know your fact families, that this is something that you can do in your head. But you need to be writing this out. You need to be showing your work. You need to be creating that balance. You need to be showing the opposite operation. Because when these get harder, when fractions and decimals are part of these, when there are x's or variables on both sides, if you haven't been practicing the strategy the easy way, you're not going to know how to do it when it gets harder. So, example 2, if I had a plus 5, and that equals 11. Again, it's an equation. It has an equal sign. It says that this expression is equal to that expression. The equal sign is the middle of your balance. That's what we want to keep balanced. That creates our two sides of the equation. What has been done to A? Notice that question is going to be asked every time. What has been done to my variable? Because if I can't identify what's been done to it, I can't very well do the inverse or the opposite of it. So if we have added 5 to A, what is the opposite of add? Subtract. So we're going to subtract 5 from both sides. When we do that, these cancel out. And you just have to take for granted that you understand they cancel out, because that's 5 positive. When you keep change, that creates 5 negatives, and that makes 5 zero pairs. So they're gone. That leaves A by itself here on that side now. $11 minus 5 is 6. Now, I really don't get in the habit of circling my answer until I have checked it, because I know every time I have an equation, I can check it. We are writing the original problem, which was A plus 5 is equal to 11. If I said that A was 6, then I'm plugging A, 6 into A. 6 plus 5 is 11, and if 11 equals 11, then I know that that was the solution and I am right. Don't forget to bring out the original problem off to the side of your Cornell notes so that you can use your notes properly. And we have one more example today. What has been done to P? Nothing. P was done to 69. 69 was there first. So I've added P to 69. But what do you know about addition? Addition is commutative. I can switch it around and get the same answer. If I had 5 plus 3, what's the answer? 8. What is 3 plus 5? 8. If I switch them around with addition, I still get the same answer. Commutative property only works with addition and multiplication. What is 5 times 3? 15. What is 3 times 5? 15. It doesn't matter the order in addition or in multiplication, and you're still going to get the same answer. This is going to make a difference if the variable comes second and you are subtracting or dividing. They are not commutative. So when we get to the point where we are seeing subtraction and division with the variable second, we have to do something totally different. But today, because it's only addition, we know we're going to get the same thing if it were P plus 69. So because it's addition, we can say that 69 was done to P. Here is the center of our balance. If I have added 69, what's the opposite? Subtract 69. So I'm going to subtract 69 from both sides. In doing that, I created 69 zero pairs on that side, and it left P by itself. I can't take 9 from 7, I've got to borrow. Now I can take 9 from 17, which is 8. I can't take 6 from 0, I have to borrow. Now 10 minus 6 is 4, so P is equal to 48. Now, I'm not going to take that for granted. I'm going to go ahead and check it, which means I'm going to write my original problem. And if I said P was 48, then I'm going to fill in 48, or substitute 48 for P. I know that 8 plus 9 is 17, 7 plus 4 is 11, so 117 equals 117, and I know that 48 is the right answer. Don't forget to come over here and take out 69 plus P is equal to 117. So we're doing the opposite operation to get the variable by itself, or isolate the variable on one side of the equation. What you do to one side, you do to the other. And then once you have what your variable is, your solution or your possible solution, you're going to plug it into the original problem and check it. That's what you're doing today. Yes, I know you can add up on your fingers from 5 till you get to 11 and know that 6 is the answer. We aren't doing that to see, yeah, do you know what is added to 5 to get 11? That's not the objective for today. The objective for today is that you know the steps to solve an equation. So I expect you to be practicing these steps when they're easy, so that when you see decimals in there and you see fractions in there, you still have a procedure that you know to do from step 1 down to still get the right answer. So yes, don't ask me, do I need to show my work today? Because I can add up from 5 to 6 to get 11. Yes, you have to show your work today. Yes, you have to check. Yes, you have to go through those procedures now while it's easy, so that you are practicing a technique that's going to make you successful when it's harder. Any questions?